Welcome to Did You Know? The ESCO HVAC Show. We will see you in about 45 seconds or so. Make sure that you are subscribing to our channels, our LinkedIn, YouTube, Facebook. Turn on notifications, and we are very excited to be here with you. It's almost time, about 30 more seconds. Make sure to grab your notebook and pen so you can jot down notes along the way, because at the end of the show, you could have an opportunity to ask our guests questions so we can dive a little deeper into these topics. And here we go. Welcome to Did You Know? The ESCO HVAC Show. All right, well, hello once again. Thank you all for joining Did You Know? The ESCO HVAC Show. So last month we had the opportunity to hang out with Chris Mohalley from Regal-Rexnord. Chris, how are you doing today again?
Doing great. Happy holidays.
Absolutely. Getting real close. Boy, we're getting excited, getting busy, and ready for a break. And
ready for the break.
Oh, my goodness. Absolutely. So we spent a lot of time talking about airflow, our true variable speed ECM motors, and they are quickly gaining popularity in the industry, but they're not the most popular ECM motor out there, at least what I see out in the field. So today we're going to be spending some time with the constant airflow's cousin, constant torque. Very similar, but boy, they have some different command controls. So Chris, thank you so much for joining us. And for those that missed last month's show, it is out there. We got the live version of it. Plus we've got the finished edited version as well on our YouTube channel, ESCO Institute HVAC Excellence. So make sure to go check that out if you missed that one. And let's go ahead and dive on into this thing. And let's talk a little bit about constant torque ECM motors.
Sounds good. We'll start right in with what you said there, constant torque, ECM, and their applications. So last time we talked about constant airflow motors, and they're more applicable to the premium level HVAC systems. Constant torque motors are more applicable to the mid-tier and lower tier systems. But as you're going to learn, there's some characteristics that cross over, which I think the audience might find kind of interesting. These are multi-tap motors. Majority of them are multi-tap motors. I have to remember to change my teaching habits because the motors have changed in the last 5 years or so. So the majority of them are multi-tap motors, very similar to a PSC motor, where if you want the motor to operate with more or less airflow, you simply move to a higher or a lower tap value. And they're also constant torque, as you already mentioned. And as we did last time, we will delve into what constant torque really means, and especially what it means to airflow. These motors do perform very similar to a PSC motor, but we'll show exactly how similar and what that means as far as making airflow selections and diagnosing airflow performance issues.
Yeah, absolutely.
So what does multi-tap mean? Pretty sure it's, what I've said already is fairly plain, but just to make sure.
Manual selections, that's really what we're talking about.
It really is. So, really the main difference between a constant torque ECM and a PSC motor is they both have speed taps. And it's funny because we call them speed taps, but even on a PSC motor, they were never speed taps. When on a PSC motor, when you want to make it multi-speed, you tap the winding in multiple places, and each tap gives you a different amount of torque. Each different amount of torque is going to give you a different amount of speed based on the load. Probably went a little too deep there, but these
makes sense to me.
we call these speed taps, but really each tap has a programmed level of torque, and that level could be either a % of maximum torque or an actual ounce-feet of torque. And again, if I go to a higher torque level, I'm going to get more airflow. A lower torque level, I'm going to get less airflow. But I'll default and go back to what the industry's comfortable
Yep.
with, and we'll just call them
Speed
speed
taps.
taps.
And they look
But
very similar. I mean, when we're talking about PSC motors, we had
yeah,
typically wires that were our selection, but on some of our manufacturers, we actually had plugs or sockets on the motor that was the
yes,
tap selection.
terminal block.
Yeah. So when we
Yep.
look at our ECM constant torques, now we're going to see a similar type of plug. And so a lot of people are familiar with that particular look. When we're getting to the actual socket, we're going to go, oh, wow. All right. That's starting to look a little bit familiar to us, right? Well, what do they mean? What are we doing with each one of these taps? Oh man, my lighting is horrible today. What is happening?
I've got mine here if you need a
There we go.
backup.
We may. I'm
Um,
gonna play around with this for a little bit and see what we got.
you're good. You're good. But yeah, so the main difference here, again, being an ECM, is we provide line voltage to the motor continuously. So as you can see in the diagram on screen, you've got LGN, line ground neutral. The N is stamped on all of our plugs, whether it's a 115 volt, 230 volt, 277, or 460 volt. It's always stamped as N. So the N changes meaning. Whether you're in a 115 volt motor, it is actually neutral. A 230 volt motor, it's going to be L2 and so on. And then the C, of course, is common. So like the constant airflow motors we discussed last time around, this motor is powered continuously with line voltage, and it is the low voltage, in this case, 24 volts AC, that actually energizes the speed taps, tells the motor not only when to turn on, but the tap that's energized tells the motor which torque level to operate at.
Okay. And for everyone that's joining us, let us know where you're joining from. We always like to know how large our community of HVACR professionals are. I'm here in Brownsburg, Indiana. Where you join us from, Chris?
Me, I'm from Racine,
All
Wisconsin.
right. How's the weather up there today?
It's actually almost 50
I know,
today,
kind of
so
crazy here too.
typical Wisconsin
Yeah.
weather. Just wait a day and it'll change. Ski hills are crying because all the snow they made last week is melted.
Yeah, exactly.
I said hills, by the way, not mountains. We don't have. I have to go out by Howard if I want to see mountains.
Yeah, he's got got a little elevation out that way.
Exactly. So yeah, and so the only other thing that I do want to cover, make sure I cover at least once, I'm sure I'll say it
Mhm.
again because I often repeat myself, is on the OEM motors, these speed taps are programmed. So the manufacturer of the appliance gets to program the torque value that goes into each one of those taps. And that's where, as we discuss later, these motors look very simple at the onset, but then they can get a little bit more complex when you understand that every OEM can program them
Differently.
differently. So so tap 1 may not always be low
Yeah.
speed, and tap 5 may not always be high speed, as an
Yeah,
example.
I've ran into that before where they were, opposing. Actually had some that came from a manufacturer one time as a warranty replacement motor, and I got some calls from the field. Hey, these are not running at the correct speed. And I'm like, what do you mean? And they're like,
Right.
low is high and high is low. And I'm like, oh, that could be an issue.
Yep, exactly. So, the best recommendation I can give technicians is to really treat these motors just like you did a PSC motor. Go to the door schematic or the unit manual, where you'll find either the color chart like we did for PSC
Right.
motors, or in this case, the number chart that tells you what each number represents as far as high, medium, low speed, or other. Some manufacturers will actually label them as the heat tap or the cool
Sure.
tap, or electric strip heat or something like that. And of course, we'll have to confer with those manuals for our airflow, because it's a constant torque motor. It does not maintain airflow like the constant airflow motor. And of course, we'll get into that in a little bit. So let's dive right
Okay.
into what makes the motor so
Yeah.
different. So almost all constant torque motors built by us and our competitors use this same, and I like to use the word standard 9-terminal
Okay.
block. CLGN 1, 2, 3, 4, 5. It comes up to 9. You got a blank in the upper corner next to N, so I call it a standard 9-terminal block. Us and the competition build our motors with the same block. Almost all of them are using 24 volts AC to energize the speed taps. So what makes them different? If you look at the diagram that's on the screen, we see, and I'm using examples of how different manufacturers program the motors. This one programs the motor with tap 1 as low speed and tap 5 as high speed. Just like with a PSC motor, if I needed my IC heat is connected to tap 3. So if I wanted to increase my heating airflow, I would move the heat tap from 3 to 4, and I would get more airflow. Very simple.
Makes sense.
So now I'll give you another example, and if you didn't pay attention, I'll tell you what changed here. Like a
I
Where's
see it.
Waldo?
Oh boy, this could have been a little
Right? So
competition right here. Does anybody see what happened between slide 5 and slide 6?
there you go. So tap 3 didn't change,
Yeah.
but everything else did. Tap 5 is now low speed, and tap 1 is now high speed. And to your point, if a technician is not paying attention to the speed taps, they may move them in the wrong direction, which, obviously you can probably figure out if your amperage goes down and your airflow goes down. I probably went in the wrong direction. You can go the other way, but it's just as easy to reference the schematic and know what you're talking about when you're working on the unit.
Right.
This next one is going to give you even more reason to focus on that unit schematic. So, and this is actually fairly common in single stage package units that use constant torque motors, because and especially if they're all electric. So an all electric single stage package unit might use one speed for AC and electric strip, heat pump, AC, heat pump, heat, and heat pump and electric strip. It may use one speed for everything, and if it does, it comes factory wired to that one speed. Now there's actually a high speed that I can choose here, but the key to this diagram is there are 3 taps on this motor that are not programmed. They have no functionality. So if I put 24 volts on tap 3,
that's what I was going to ask.
the motor's not going to run.
Okay, absolutely. That makes sense. So it depends on how it was programmed from the manufacturer. No program, no run.
Absolutely. So if I'm used to working on systems that look more like the previous one, or either one, I might think that going up to tap 3 is going to give me more airflow. The motor shuts off, and then I'm wondering, well, do I have a bad motor? Because I don't know enough about constant torque motors. So this is really probably more important for diagnostics, but also important for that technician that shows up on the job. They've got a frozen coil or a tripped limit, and they move to it inadvertently. Again, package systems common, split systems very uncommon to have unprogrammed taps, but they inadvertently move to a tap that has no program in it, motor shuts off. I mean, I myself, if I didn't know better, would think something wrong with the motor.
Bad motor. I mean, that would be the call that would come in.
Right. That tap's not working.
That is a fantastic. If we get anything from this entire program, that is some super good information. One of the questions just came in from Sean. Thanks for joining, Sean. Thanks everyone for joining us all the way, even from Pakistan. We have a really good reach today. I appreciate everyone joining us. Yes, absolutely. This will be in a couple different places. You can come back to our LinkedIn, Facebook. You can check it out on YouTube Live. You can also come back. It'll be an edited video within a couple days. And if you are needing any continuing education hours for this, you can actually go over to our e-learning network. And all of these shows get turned into videos. They're basically e-learning modules with assessments that go along with them. And so for $2.99, you can actually take a test. And if you pass, then you'll get a printed out certificate of completion for not only watching the show, but retaining the knowledge from the program as well. So a variety of different ways to check this video out later. So good question. Thank you.
They should get something for just having to listen to me, if you ask me.
That's good stuff. Anyway. It's called getting smarter. That's what they're getting. That's what I'm getting.
All right. So here's another example. And this is pretty common in air handlers from one manufacturer. I'm not going to say who the manufacturer is. But you see a low, medium, and high. And so, when I go back, I'm just going to go back a couple of slides. So, if a manufacturer programs all 5, whether they program tap 1 is low or tap 1 is high, tap 3 stays the same. It's medium. And you might start getting the mentality that, well, the middle of the motor is always going to be medium. Well, that's not the case. If you look at this particular air handler, where they did low, medium, and high in 1, 2, and 3, and then they put tap 4 as the dedicated electric strip tap, and then C manual for tap 5, which my joke in class is always, well, that tap's never going to get used because the manual's
they actually have to open the manual to read this one and know what it is.
Well, not picking on the technician that's currently on the job, but not a lot of manuals stay on the job.
Exactly. We're talking to the technicians that don't read manuals. We're just encouraging them. Everybody else does, and we're so glad that you do.
So this is my cue to throw out the RTFM. Read the full manual.
Man, I got to get with you later in a private chat because I really want to know the manufacturer of this. I know we can't do it openly, but maybe I can guess until I see like a wink or something. We'll talk
You could
about this
probably
later.
guess. It's
I think I might
pretty
know, but
obvious if you've seen
yeah,
this one. So those are some examples, and I'll just go to that
sure.
slide. Those are some examples of the most widely format that constant torque motors are used
Okay.
in.
Not very
All
many.
the 5 taps are 24 volts AC activated. The 24 volts AC turns the motor on. The tap selection determines how much torque it puts out. The manufacturer that programmed the motor tells you if it's low, medium, high speed, and away you go. Very, very simple motor. Funny that you mentioned earlier, PSC motors having terminal blocks. In the past 5-10 years, there's another competitor of mine that puts out a constant torque motor that looks like a PSC
Looks like a
motor.
PSC replacement.
That's actually, and I'm sorry for pointing that way.
No,
I've got it on my bigger
that's
screen
right.
here. That is actually a constant torque motor with just
I'll be
leads,
darned.
no plugs.
Sure.
It has the same line, ground, neutral,
Still has to be
common
wired the same way
wires,
as
and then it
these.
has 5 24-volt wires
Okay.
for its speed taps. So very, very similar, and also very widely used by one
Yeah.
manufacturer. We put out a new motor recently called the N-Sight motor, where we changed the plugs. We went from the standard 9-terminal plug to 2 different plugs, and that was released primarily in 115-volt motors
Okay.
for the fossil fuel market. So I'll talk about that in a little bit, and then, well, probably next slide.
Sure.
And then there's also two communicated modes for constant torque motors. One of those communicated modes is called PWM, and one is called 9-speed. And technicians that are paying attention to the manuals or the schematics are probably already seeing these because they've been out for quite a while. But I'm starting to get, I do tech support for us, so I'm starting to get more and more questions on these. So I'm recognizing that the awareness has grown on these motors. Manufacturers will take one of our motors, a technology that's new to the industry, they'll use it, and it'll take technicians a while to actually notice that
Something's different.
changed in the appliance.
Yeah.
So some of these have been around for a while, and I'll talk about that when we get to
Sure.
them. But that's the evolution of constant torque in one
In a nutshell.
screen, if you
Yeah.
will. Again, 90+% of what's out there is that standard 9-terminal with the 24-volt speed taps. You've got some still using wires only, and then you've got a couple of new terminals and PWM and 9-speed. So let's dive right into,
Sure.
unless you had something
One
to add.
little question. So a good comment.
I saw you looking.
Yeah, good question came in from Ray about, so how do you get the correct programmed motor for your application? One, you go with the OEM motor, or you go with a replacement motor and you verify what your CFM ratings were on your OEM motor, and then you just look on your new motor. I could be wrong, but that's the experience that I've had with replacement motors. How would Gentech approach that one?
Yep. No, you said it perfectly. If you want the exact motor that came out, you would have to go back to the manufacturer of that appliance, order it from their authorized distributor, buy the model number of the appliance to get the program motor that came out of it. But we do make generic motors that have all 5 taps programmed, and it's very just like with replacing a OEM PSC motor with a generic PSC motor. We can replace an OEM constant torque motor with a generic constant torque motor that has 5 speeds. And as you said, I'm going to adjust my speeds until I get the correct airflow. So since it came up now, and it'll come up later again because it's in my slide deck. But so I often get asked, well, I like to go back with OEM motors because then I know all I have to do is plug it in and I'm done. I don't have to measure airflow because I put the OEM motor back in, and my contest for that is, well, what if when the system was first installed, what if no one ever measured airflow and adjusted the speeds to set it up properly on day one? And then I get the and the gosh golly and the kick in the rocks, and then I take it a step further and say, now I'm really going to blow your mind. These are constant torque motors. What if the static pressure today is different than the static pressure that it was on day one, even if it was set up properly? If my static pressure is different today, then my airflow is different today, and I still have to measure airflow. So bottom line is, you're going to have to measure airflow whether you're putting the OEM motor back in or a universal motor back in. So really, putting a universal motor back in isn't any more time than putting the OEM motor back in, as long as you're following industry best practice.
Absolutely. Jason Abjute from our team says this all the time. He says compressors don't die, they're murdered. And it's kind of the same way with ECM motors. You
I
know,
love that.
ECM motors don't typically die on their own. It takes a lot to kill one, but boy, they can easily be murdered if they're not set up properly and they have too much static pressure and
I
other
would agree
issues.
with that wholeheartedly. Yes, sir. So we'll move on to the first variation, if you will, which is what we call the Insight motor. Again, we launched this in
Hmm.
2019 with the 2019 fan efficiency regulation change. 115 volt only, but it has two different plugs. But if you look at it really closely, it's the same
Oh
motor
yeah,
as what you're used to. You got the 9-terminal plug here, and I'm marrying it up to the three terminal plug for line
sure.
voltage and the 6-terminal plug for low
Different
voltage. So
configuration, but yeah, it's all there.
yep, yep. And so you're probably only going to see this if you're a technician in a fossil fuel market,
Mm,
because
right.
today we only
Gas
make it in
furnaces.
115 volt
Yep.
applications, which means it's fairly new to the industry as well, because it's only about 3 years
Okay.
old. Well,
Yeah.
almost 4 years
Right.
old now. Coming up on its
Getting close.
birthday. There you go. And this motor is, by the way, also capable of the 24 volt speed taps, and also the PWM that we're going to talk about
Oh,
in just a
okay.
minute. So just a minute.
Right. How
How
about
about
now?
next?
And next.
It's pretty bad when I'm leading in
That's
myself.
perfect.
So PWM, and if you're not familiar with the acronym, it stands for pulse width modulation, and all it is a DC duty cycle. If I speed up the duty cycle, I'm asking the motor to operate at a higher torque value. If I slow down the duty cycle, I'm asking the motor to operate at a slower duty cycle. So from a really fundamental standpoint, if I think about the old rheostats,
Oh,
I
yeah.
turn them up and the motor goes
Mhm.
faster, or the light gets
Mhm.
brighter. I turn them down and the
Mhm.
motor goes slower, or the light gets dimmer. With PWM, the OEM board has full control over the motor. If they send a really low PWM signal, they'll get a really low output out of the motor. If they send the highest, if 100%
Mhm.
PWM signal, they're going to get maximum output of the motor.
Makes
So they
sense.
they literally can have infinite speed control of the motor in PWM. One thing that technicians can, because again, the manual is not often on the site, the schematic may not specifically spell out this is PWM, but one thing that technicians will notice when the constant torque motor is used in PWM is tap 1 and terminal C, or sorry, terminal 1 and terminal C are going to be typically wired back to the board through a plug.
On their own.
Versus,
Okay.
yeah, versus if you remember, and I'll go back just a couple of slides. If you remember here, on all of our 24 volt motors, the motor terminals are going back to heat taps, cool taps, fan taps, and if they're all wired, park or unused taps. But in the case of PWM, what they're going to find is it's not going back to a heat, a cool, a
It's
fan.
dedicated.
It's going back to a dedicated plug, because you're not meant to adjust that
Yeah.
tap. You're
I don't
meant
wanna
to
put
leave that
24 volts AC
alone.
on that thing.
And no, and it's not going to be 24 volts
Mhm.
AC. The PWM signal is created with
DC.
DC voltage. So you'll have to, again, go into the manufacturer's manual to find out what that DC voltage is that relates to the PWM signal. And I think I've got one more slide on that. So that's kind of what a PWM signal looks like. And again, that signal determines the motor torque, which determines the motor's output. So on a PWM controlled motor, you're going to adjust your airflow with the dip switches. So here we are. We talked about constant airflow last time around, and how everything's going to be set up with either dip switches or jumper pins, or today's communicating thermostats. I'm going to go in
Mhm.
and I'm going to adjust the menu
Mhm.
selection. Now here we are with constant torque motors, and they're right back to that form of, we use PWM
Yep.
communication and constant airflow as well. And now we've got constant torque motors using PWM and being controlled by the dip switches on the board. I see a question came in. Do you want to hit that
Yeah,
question?
yeah, Todd's always got the good questions because it's kind of following along with me as well. So if we look at pulse width modulated motors, is the program stored in the board or is it stored on the motor itself? And is it pretty universally accepted between motor manufacturers for that?
I love intelligent questions, and
Mhm.
that is a great question, because if you and whether you remember our previous discussion about how constant airflow motors are uniquely programmed, and there's a lot of unique OEM information stored in the motor. In PWM mode, there is not much stored in the motor. The
Sure.
only thing that's really stored in the motor is a max value and a min
Sure.
value. So, and most OEMs are going to use the full scale of the
Mhm.
motor because they the value of PWM really if you're like me, a former technician, right? You're looking at these. Why can't they just keep them simple? 5-tap motors. Just leave all this communication stuff alone. Well, from an OEM standpoint, the value of this is I can have one motor now cover multiple
Yeah,
platforms, right? I can have it
absolutely.
cover my fossil fuel furnace, my split system air handler, my package
Package.
systems,
Yeah.
because all the motor has to have is a min max
Give me a
value
signal.
and a rotation value. That's all that's stored in the motor. And then the board can send so I reduce the SKUs that I have in
Brilliant.
manufacturing when I'm building my
Yeah,
appliances.
absolutely
For, u-
brilliant.
for us, what we need to understand is that PWM signal controls the value, but in the motor, there is a min-max.
Mhm.
So is it possible? So this motor, for example, has a 600 to 1200 RPM design range. So if they choose 600 as the min and 1200 as the max, then the PWM signal, 50% PWM signal is going to run around
Yeah, half of it. Yeah.
750
Mhm.
RPM, roughly in
Sure.
there. And then, of course, remember, this is torque, not RPM, but that's approximately where it's going to run. If they so chose to make the min 600 and the max 1000, which I don't know why they would do because they'd limit their own scope of capability of the motor, then a 50% signal would give me a 700 or 600 and whatever, whatever 50% of 600 to 1000 is. So that's the only thing that's stored in the motor. So what we've noticed is that with the generic motors, we open the range up all the way, and we find that most OEMs are doing the same thing.
Mhm.
So you're going to be able to, again, take a universal motor that is PWM capable, which the motor we sell, the Evergreen EM is PWM capable. You're just going to be able to plug it in, and it should run the same airflow that the old motor was running. And I'm going to pause and say that still doesn't mean it's the right airflow. It just means it's going to
Right, what
run
it's
the
being
same
told to run.
airflow.
The old motor was
Right.
told to run.
So if it's being told to run the factory default airflow and that's not right for the
Yeah.
system, then we still need to make adjustments. I see another question or two came in. Do you want to hit those?
It's up to you unless we wanna save them towards the end and, because some of this might be covered as we go along.
Okay. Yep. And I think we answered at least one or two of
Yeah.
those. So yeah, PWM signal, as long as I have the OEM manual, I can adjust my airflow with my dip switches. If I don't have the OEM manual and my airflow is incorrect, static pressure is really not going to be of much value to me because I have no idea what my selection is. Obviously, unless my static pressure is like 1.7
Yeah,
or
exactly.
something, which is
Be
completely
Yeah.
outrageous. So these have been around, at least from us, for over 10 years across a couple of different platforms, the Enduro Pro, the new N-Sight, and the new N-Sight Air. And I believe that other manufacturers of constant torque motors are also using PWM. So, I usually say this at the beginning, but I try and keep our discussions less product specific and more technology specific, so that the people that are watching don't think, well, I just went to a Gentech class.
Sure.
Well, you kind of are, because I work for Gentech,
Absolutely.
so
You're
I
gonna get some
have to talk
branding.
about our stuff.
But
But
what's in the
what
branding?
you're
That's what we're here for.
right. But what you're learning in this presentation will apply to almost any of my competitors'
That's amazing.
constant torque
Sure.
motors. They almost all use the 9-terminal plug. The one that doesn't uses the flying leads, but they're all constant torque. The ones that are using PWM are going to use PWM in a similar fashion, and to my knowledge are also using pin 1. So a lot of this information will cross over to my competitors'
Very
products.
nice. And for those that want to learn more about the motor mastery side, we highly encourage you to go over and check out the Motor Mastery site for Regal-Rexnord. Tons and tons of additional training, especially on brand specific products. It's a great resource. I mean, I've went through it myself and enjoy everything that is there. So make sure that you're keeping up to date with what's changing here at Regal-Rexnord.
Appreciate that. Yeah, we've worked really hard to make that an excellent repository for all of our branded products information, and a lot of general motor information as well.
Absolutely.
So now we're shifting gears
Mhm.
again, and hopefully by now, anybody that logged in thinking, well, I know
Yeah.
constant torque motors, I'm not going to learn much here.
I've learned
Hopefully
a
they're
lot.
already going, well, I'm glad I tuned
Yeah.
in, because there's a few things I didn't know.
Right.
So there's another variation of constant torque motors called 9-speed. And 9-speed, when you hear it, when I explain it, and if you're looking at on the screen and you're the punchline's on the
Right.
screen, it makes complete
Sure.
sense. But before you would say, well, how do you turn 5 taps into 9 speeds? And you simply do that by doubling up taps. So if you put voltage on terminal 1, tap terminal, sorry. If you put 24 volts AC on terminals 1 and 2, you get speed 6.
Sure.
Put it on terminals 1 and 3, you get speed 7. Now, if any of you have been in my class previously, you'll remember that when I taught the original constant torque motors that were just 5 speeds and 24 volts AC, I taught that the original 5-tap configuration had a hierarchy built into the motor. And what that meant is if tap 5 and tap 3 were energized at the same time, the motor would operate at tap 5 and ignore tap 3. So when we started offering 9-speed mode in this configuration, that hierarchy obviously has to go away so that we can make room for the motor to recognize when 2 taps are being energized. I want that to equal a new speed. So again, in this configuration, oh, by the way, I should also mention that in 9-speed mode, like PWM, where we're no longer necessarily using 24 volts AC, the manufacturer could choose to use AC or DC voltage as the enabling voltage in 9-speed mode. So don't assume that just because you see a motor, a constant torque motor with a standard 9-terminal block and 5 wires attached to it, that it's AC. You probably need to go to the schematic. And even more so, if you see those 5 terminals wired directly back again to a plug. Not to a heat terminal, not to a cool terminal, but back to a plug. So that's so it's a couple of things that should, light bulb. I should have asked you to have the light bulb graphic ready. A couple of things that should put a light bulb off in your head. One, this is not a multi-tap motor. It's not meant to have taps move to change speeds. And 2, that voltage on those taps may not be AC. It may not be 24 volts AC. It could be a DC voltage. It's not going to be a PWM, but it could be an AC voltage or a DC voltage simply as the enabler to turn on that tap. So in this mode, again, you're going to be using dip switches to select your airflow. And if you don't have the right airflow, you will need the manual to not only find out which terminal or terminals should be energized in relationship to the dip switch settings that have been selected.
Yeah, it makes sense. And so it's a direct connection from the motor back to the board. Once you make your dip switch selections, the board is going to determine which of the pins are getting energized together.
Right. So in 9-pin mode, or 9-speed mode, sorry, the motor actually does have 9 discrete speeds stored, and they're accessed by how you energize the pin or pins. And I'm going to go backwards one. In PWM mode, it is literally a variable signal, and the manufacturer has full control of the motor. It's not 9-speed, it's not 20-speed, it's unlimited speed. The manufacturer can program as many speed variations as they would like in PWM mode. All right. Do we have any questions we want to hit before we move into airflow, or are we
let's
good?
take a look real quick. I know there were a few that come through here. Manufacturer label AC or DC. Yeah, so when it does come to the actual signal going to the module itself, do we see much discrepancy between manufacturers, or is there any type of label for us to be able to measure AC or DC, or just start switching through?
Yeah, so when we ship the motor, our label is going to be on the side of the motor, and it's usually on the end. And the voltage listed on this label will be the rated line voltage. The 24 volts is only listed in a very, very small. You wouldn't even see if I held it all the way up to the camera, in a very small legend over here. Where you're going to want to look for that value as to what's going into the motor is on the schematic on the door for the unit, or in the manual. What did they choose to program that motor? Because as an example, now you have, so this is our current Endura Pro. It looks a lot like our next generation N-Sight. Only difference really is that you can see the heat sink over here on the one, and this little white box on the other. And I've been asked quite a bit, so if you don't mind, I'll throw it out here. I've been asked, why did they get rid of the heat sink and put this little plastic cover on here? That plastic cover is actually covering the NFC control, which is near field communication. And that allows manufacturers to now program these motors while they're coming down the
Yeah.
line by just swiping
Yeah.
it.
Love it.
Same way you pay with your phone
Yep.
with the Apple Pay, you just tap your phone. That's NFC. So that's the difference. We didn't take the heat sink
Mm-mm.
away. But,
Looks
so
like it just
to make room for
relocated it
that, we
onto the bottom.
we just basically
Yeah.
relocate it. Yeah, still has the same heat sink value, just built in a different fashion.
Mm-hmm.
So what I was getting at before is, now you've got quite a few motors, not just including mine, that all look the same.
Yeah.
This motor here could be 24 volt AC speed taps. It could be PWM, or it could be 9-speed using AC or
That is
DC on the
interesting.
speed
Yeah.
taps. And you wouldn't know
No.
that by looking at the motor.
You
You'd
have to
have to
look at a
go to
diagram.
the manufacturer's literature to find out how it's been
Yeah.
programmed.
Wow. That's quite interesting. So,
Yeah.
it's neat to see the changes, but when we look at the diagrams, it actually simplifies how they're running. I mean, you're going to know when you look at the wiring diagram for the control board which style it is. So,
Yep.
okay. Very, very cool.
Yep. And we'll run through the
Yeah.
diagnostics in a little bit, but we've kind of overviewed all that so
Right.
far, and we'll like I said, we'll return to that with diagnostics. So these are constant torque motors. If you look at the screen, you can see the upper chart is a PSC motor, just one torque output over the static pressure range, and the lower one is the constant torque motor. And really, if you look at these, and obviously I picked 2 half horsepower motors. I picked 2 similar speeds or torque
Mm-hmm.
values so that they would line up. And you pretty much start out at the same airflow at 0.3, and you end up pretty close to the same airflow at 0.9. But if you look closely at the two, you will notice one thing, and this is where it can get a little confusing. So both motors decrease airflow as the static pressure goes up. Period. End of statement. No other way to say it, right? When static pressure increases, both of these motors are going to decrease airflow.
Yep. They're both going to struggle.
They're both going to struggle. But if you look at the constant torque motor compared to the PSC motor, it actually does a little better job at the end of the static pressure
Mm-hmm.
range than the PSC motor. That's because it is, quote unquote, constant
Right.
torque. So being a constant torque motor, it's going to maintain torque on the shaft when the load decreases. And of course, the load decreases when the static pressure goes up, because we've
Yeah.
restricted
Pressure.
airflow by one mean or
Mm-hmm.
another. When I restrict airflow, I reduce the amount of volume of air the wheel can move, and that's less work for the motor. So the motor does less work. But the constant torque motor will maintain that torque at the shaft. So I do get a little better airflow performance than a PSC motor, but I almost slap myself right when I'm going to say that and say, don't say that. And I have to say it because you can see it on the screen, but I don't want anyone to think that this motor compensates in any way or is going to maintain airflow, because it doesn't. It is not a constant airflow motor.
Yeah, absolutely. All motors are going to struggle with our higher static pressure. And another important thing to look at it too, when we're looking at the static pressure charts, these ranges are for a reason. And so when we see static pressures that are above the
Yeah.
rated OEM specs, it's our duty to correct those issues, whatever those issues end up being, because it's not designed to operate above that parameter. We start having a lot of difficulties.
Exactly. Yep. So we'll move on to the next slide, where I pulled up the amps and the watts in relationship to CFM. And this is where you can actually see the difference between PSC motors and constant torque motors. You can actually see, hopefully help make that constant torque word make some sense. And if you look at the amperage on the constant torque motor, it actually goes up, which is counterintuitive to the airflow going down, because you think, well, the motor's doing less work. Well, it is doing less work than the PSC motor, and the airflow is decreasing, but the motor is actually using a little more current, because in maintaining torque, we actually have to increase the RPM to maintain the same torque on the shaft when the load point changes. So when technicians see this, or I teach this, it becomes a real difficult point to understand. Well, how can the motor be losing airflow but increasing in current? And that's when I like to point out, if you look at the entire amperage range there, we're only changing from 0.3 to 0.9. We're only increasing by what, 0.7 amps, which is very, very little. I also like to point out on this chart, when technicians will say, well, that ECM motor is going to burn up when the total static pressure is high. In the case of the constant torque motor, that's really not a good assumption, because even though anytime I use more current, I increase the heat in the motor. Anytime I increase the heat in the motor, I decrease its life. But this motor is not using much more energy at 0.9 than it's using at, say, 0.5.
Sure.
So even though high static pressure is going to decrease the life of the motor, you have to say that because it is using more current. It's unlikely that that's the most likely reason why that motor failed. And we'll talk more about why the motor could have failed if it's not that later.
Okay.
But I wanted that's really one big difference between the constant airflow and the constant torque motors. Constant airflow motor, yeah, it's like cruise control, as we
add some
mentioned. It
RPMs
is going to speed up. It is going to draw a lot more current, and you are absolutely going to prematurely fail that motor, the constant airflow motor, if you run it at high static over its entire lifetime. But the constant torque motor, not so much. You're not going to have the airflow you need, but you're probably not going to burn out the motor as likely as you would, with the constant
I get
airflow
that.
motor.
Makes sense.
Okay. Any questions there? Did we miss any
just
questions?
one that came through.
Yeah,
Robert came through and had a question about the actual programming of the motor. I wasn't sure if we should save this until the end or not.
Yeah, let's save it until we talk about the diagnostics.
Yeah, that's what I was thinking.
But let's make sure to hit it then, because that's a good question. So just to wrap up the airflow, I made a generic chart with multiple taps, so that you can see that if I move from one tap to the other, I am still going to decrease airflow over all taps. And this is, I really put this chart out there so the technician would realize it doesn't matter what the manufacturer selects as the default tap at the factory. It doesn't mean that airflow is going to be the correct airflow as installed in
your application,
whatever house it's going in, because the static pressure is really going to dictate the operating point of that motor. And there are some manufacturers that will actually, in their schematics, they'll show tap 3 wired back to the board and call it the heat tap. And that's where I get into some real heated discussions. Well, the manufacturer says it's the heat tap.
Right.
Well, that could be, but if your static's 0.9, you're going to trip the limit on that heat tap.
It may be at the perfect lab setting of 0.5 inches. That might have been exactly what it needed, but in real world installations, we have to verify.
Right. Exactly. So that was the only reason for throwing that up there. So let's jump into diagnostics. And I do get questions about the diagnostics. We have the Tech Inspect tool. It's been around for quite a while. It's used for diagnosing the constant airflow motors with the 16 and the 4-pin plugs. And I get asked quite often, will that tool diagnose constant torque motors? And the answer is no. And really the reason for the answer is we just didn't think it was worth, adding the capability to that tool when the voltmeter on your truck will do the same job. Right. Instead of taking out a special tool and plugging it in, figuring out how that works, just use your voltmeter, because all that's going to be coming to this motor is either AC or DC voltage. Even in the case of PWM, most manufacturers in their manual will say, with the dip switches set to XYZ, the PWM DC voltage on tap 1 should be X.
Excellent.
And maybe that's 9 volts DC, whatever it is. The manufacturers realize, at least today so far, that most technicians, very few technicians, if any, have a PWM meter. So they're going to give that PWM signal in an output in a DC voltage that we can measure with our basic meter.
Makes sense.
Also, another quick plug, if you don't mind, on our app, the Dealer Tool Belt, or our website, thedealertoolbox.com, you can download our free ECM service guide, or look at it in the app. You don't download it in an app, sorry. The service guide covers 90% of what we're talking about here as far as diagnostics in the next couple of slides. So it'll tell you how to diagnose constant torque motors, all free. And there's even some videos on the site and in the app that you can reference as well.
Very good. Good stuff.
So again, referencing the most common application of constant torque motors, the 24-volt AC multi-tap motor. If this motor is not running, I need to have either 24 volts AC or line voltage. I'm sorry, I need to have both 24 volts AC and line voltage for the motor to run. It can't be one or the other. If I only have 24 volts, it's not going to run. If I only have line voltage, it's not going to run. I have to have both. So if I don't have both values, then I have to go back into the OEM manual, find out where I lost that voltage and fix that problem first. That's not a motor problem. If I do have both of those values at the motor, and I'm just going to caveat once with assuming that on the schematic, that tap isn't identified as not used or not functional, which again, more common on package units, less common on split systems, but make sure you don't, go get a motor and find that's the problem because you didn't check that one thing. As long as that tap is a functional tap per the schematic, if I have 24 volts between C and 1 or C and the terminal and line voltage at the motor and it's not running, it's a failed motor.
Pretty simple.
I do want to, yep, very, very simple. This is about the time usually somebody says, well, what if the motor's only trying to start? It's kind of rocking back and forth and it won't start. Or what if it starts and stops, starts? As long as those voltages are constant, if the motor's not running properly as you would expect it to operate, if it's just trying to start, or if it starts and stops, or if it intermittently turns off and those voltages are constant, the motor's failed and it needs to be replaced.
Absolutely.
And we'll talk later about, I'm sure somebody will ask, we'll talk later about can I replace the control separately from the motor? But for now, let's just say the whole thing is failed and it needs to be replaced.
Sure, absolutely. I get the questions all the time. How do you verify the voltages on an ECM constant torque motor? What's the easiest way? So, the easiest way is to go over to your thermostat and put it on fan. Give it a call.
Right.
So now that we at least have a signal for our fan to run, and then we should have our high voltage and our low voltage as well.
Yep. Well, and somebody asked the question, so let's just go ahead and pause here and answer it if that's okay with you. Todd asked, bad motor or bad module. So, and before I answer that question, Todd, I do want to say one thing. Learned from the school of hard knocks, like a lot of us did, and got corrected by instructors, hopefully like me. That voltage has to be measured between the speed tap and the C terminal. It can't be measured between the speed tap and common. If that common wire is open between the motor and the board, the motor won't run, even if you measure 24 volts from a tap to ground.
The ground, sure.
Yeah, so you want it just like measuring across a contactor. You want to measure both sides of the contactor, not one side to ground. So I just wanted to mention that really quick. All right, so the question was, is it the control or is it the motor? If I've measured all these inputs, I have all the inputs I should have, and the motor's not running, you can say the control is failed. If there are control-only replacement parts available, then you need to take it one step further, turn the motor off, wait 5 minutes, pull the control out, and ohm out the motor. And we can, if Clifton wants to give me time, we can go over that at the end. I did put slides on diagnosing the motor by ohms in the appendix if we want to go there. But at this point, you don't know whether the control is the only part that's failed. You do know the control is failed, but you don't know whether the motor is still good or bad. So hopefully that answers your question. And then again, later, if we have time, we can go over the diagnostics on the motor. I don't cover it as much anymore, primarily because very few OEMs are still offering the control only, the module only, sometimes called the R mod part. More and more OEMs are only selling or stocking
the complete assembly.
The complete assembly.
Yeah, exactly. And that was an issue when we first started talking about motors. Can we stock different parts? And I have noticed that myself. Most manufacturers have went with complete motor assemblies. And if we want to dive deeper into that one, maybe we can follow that up on our fourth conversation that we have, because we have a lot of things still to cover yet today.
That works for me. All right. So we'll go on to the, we got lost here. We'll go on to the PWM motor.
Sure.
So if a motor's in PWM, there's going to be one wire to terminal 1, and both terminal 1, and terminal C are going to be wired back to the board through a plug. So the only place I can measure voltage is at the motor. In this application, I do want to get out the OEM manual. It is going to be DC voltage. So I can tell you it will be a DC voltage. It won't be AC voltage. You can set your meter to DC voltage. What I can't tell you is what that value will be, right? So I can say it's probably between 2 and 20 volts. Don't necessarily write that down and make that your gospel.
Exactly.
But if you see between 2 and 20 volts, the motor should probably be running. But the manual will tell you exactly what that voltage, that DC voltage
That
value,
range.
right, will be. But again, we're back to the same diagnostics we had with the AC activated motor. I can't have just line voltage. I can't have just the DC voltage. I have to have both. If I don't have both, I need to diagnose why I'm not getting one or the other from the HVAC system. If I do have both, the motor should be running. If the motor's not running and I do have both, and I've checked with the manual that the DC voltage I'm measuring matches what the manufacturer says I should have, then I can consider it a failed motor. But I would strongly recommend you don't consider it a failed motor until you've referenced with the manufacturer, either by tech support or by manual. It will almost, it's very unlikely that it's going to be on the door schematic. You're probably going to have to reference the manual.
Installation manual, yeah.
I don't know if I mentioned it today. I think we mentioned it last time. You can find a lot of manuals today just by Googling the model number of an appliance and the word manual. So that's a good place to start from as well.
Yeah.
But if you can't find it there, obviously contact the manufacturer and ask them.
It's not like the old days when we had a milk crate full of manuals in between the seats. Now you can actually get them on your phone, which is a pretty cool thing.
And I get teased all the time for this background because that's not a background I chose to show you. That is my office. That is what used to be on my truck, and my please don't show that, Lars. So my technicians would joke with me all the time. How do you fit parts on that truck? Because I had an entire shelf.
Yep.
Full of manuals, but who do you think they called on the old two-way radios when they needed tech support? Yeah, because I had the manuals on the truck. So some of those probably need to go because they're probably outdated equipment. But anyway, so that's PWM systems. Again, very simple as long as you understand you're going to be looking for a DC voltage. Again, want to remind you that if you see a constant torque motor that has this very recognizable 9-terminal plug, and the C and 1 terminal are wired back to the board to a plug, not a heat tap or a cool tap, it most likely is a PWM system, and you're going to want to get that manual to find out. You're going to need the manual any way you slice it. You're going to need it for diagnostics. You're going to need it for airflow selection. You're going to need it if your airflow is incorrect and you want to know, what is the selection and how to adjust it.
Sure. Now, I do have a question for you. This is actually just out of some of my personal experience. One of the reasons I've told technicians in the past to set their fan, their thermostat switch, the fan switch to on, is because some of the manufacturers that I have seen put the OEM default fan speed at about 50% of its range. Do you see that very commonly?
For constant torque motors in general, or for all ECM?
Yeah, just in constant torques.
Yeah, and not necessarily at 50%. You probably get, that is something I used to say a lot, and it's back. And I've been teaching these motors since before there was a constant torque motor. So before there was a constant torque motor, and I was only teaching constant airflow motors. Our constant airflow motors had an operational range of 200 to 1500 RPMs. So when I said they used to run at pretty much 50% of their range, that was accurate. And if you think about a basic PSC motor being 1075 or even 825, if that OEM was operating that ECM motor down at the 600 RPM range, it was significantly quieter and significantly less energy consumption than the PSC motor that was there before. So that made a big deal. In constant torque motors, they'll often run the continuous fan much lower than 50% of its capability, because most of the constant torque motors have an operational range of 600 to 1200 versus the 200 to 1500. So
that does make sense.
It's not uncommon for me to see, and I don't ever get to see the values that manufacturers program into the motors, but it's not uncommon to find a tap that's significantly lower than the taps above it. In other words, tap 1 might operate at a very low airflow value, and you might see that in the charts as well. And then 2, 3, 4, and 5 seem to there's a gap, and then they have a sort of regular intervals in their design. So that is somewhat common, but not that 50%. That if you heard that from me, it was in reference to the constant airflow motors.
Get that out of the brain.
Out, but it was more common. Yeah, it was more, well, not antiquated, but more common when I only was teaching constant airflow motors. So.
Okay, makes sense. Well, thank you for that. Like I said, that was more of a personal one, and just as an educator, I always like to see, is it still relevant?
Yep. Absolutely. So we covered PWM, and that leaves us with 9-speed.
Yeah.
And again, in 9-speed, you're still going to be looking for, and I switched over to the new motor so you could see how that would work with the two different plugs. In 9-speed, you're still going to be looking for two values, the line voltage value and the low voltage value. Again, in 9-speed, it could be AC or DC, so I put the question marks up there. I also do want to remind you that, and if I didn't say it before, I apologize, the line voltage to a constant torque ECM motor, just like with the constant airflow ECM motor, is continuous. It's there whether there's a demand from the thermostat or not. So you don't need a demand from the thermostat to check the line voltage. It should always be there. You need a demand from the thermostat to check the command to the motor, the low voltage command. So just like with all the other diagnostics, you need them both. If you don't have them both, go back to the OEM manual, find out whether that is receiving AC or DC voltage and what that voltage value is. Set your meter to the appropriate setting and look for that voltage. If it is getting both and it's not running, then of course we're back to a failed motor condition. Again, whether you have this is the newer motor, the N-Site with the separate 6-pin low voltage plug or the standard 9-terminal plug, if you see all 5 speed taps wired directly to the board through a plug, they're not going to a heat terminal, a cool terminal, or a fan, you probably have a motor that's in 9-speed mode, for lack of a better description.
Sure, absolutely.
And yeah, again, as your reminder that you're going to need the manual for the dip switches, and you're going to need the manual for the diagnostics. I should say, and I'll just reference our motors, because I don't have as much knowledge, obviously, of my competition's motors. In our motors, if you go back to the, you know what, I'm going to just real quick do this because it's not going to take that long, and I can soft shoe while it's happening. So in our motors, literally 85% of what we build for manufacturers is going to be that 9-terminal motor with 24 volts AC speed tap. So anyone watching, I didn't want anyone to get the opinion, whether they are watching now or watch later on the recording, they come in and catch a few minutes and go, oh my God, these motors are as complicated. They're everywhere. No, the PWM mode, yeah, the PWM and the 9-speed mode are really still in the 15 to 20%, maybe 25% tile of what we're making for manufacturers. Okay. Still the large majority is going to be the 24 volt AC activated motors. Now that's probably going to change in the future because
especially that PWM.
Especially the PWM, because for the OEMs, again, that gives them the ability to reduce the amount of SKUs that they carry, which is also good for the technician, right? Because if the OEM has less SKUs in the OEM equipment, that means that there's less SKUs in the OEM aftermarket as well. But I did want to mention that so that anyone watching,
a really good one,
wasn't ready to jump off the cliff or anything because because of all this, technology. It used to be this
ECM overload.
Anyone that's heard me teach this class has heard me start off by saying this is the simplest ECM we build. You're going to love this motor, and now it's not so much the simplest motor, but
I got some variations of this to talk about.
Some variations to talk about, absolutely.
Okay.
So that brings us to the failure mode. So if anyone's been to my class, you heard it in the last video. I'm very big on why did the motor fail. I'm very happy when a technician isn't part swapping. They're actually taking the time to diagnose whether it actually is failed or not. But the next step, the most important step, is why did it fail? And you can't always find out exactly why. I mean, if you pull a motor out and it's completely rusted from end to end, guess what? It got wet. If you pull a motor out and the windings are all black and this white plug is all black, it got singed somehow, whether it was a surge or
surge or something,
ground short or something else. But it's not always obvious. So of course I get asked, what do I think is commonly going to fail this motor? And this is, I'm not as technically cool as you, so I can't do like a Jeopardy thing here, but let's give your people out there a few seconds.
Yeah.
Which one do you think is the most likely failure mode for a constant torque ECM motor? Is it going to be water damage, voltage spikes, or high static pressure?
Yeah.
Boy, I didn't let you know that you could have had some Jeopardy music.
I could have. I would have, or had the guitar out here or something. I would have made. Well, we've got music back here in the background. I don't know if there's anything. Oh, maybe There might be one that's worthwhile here.
That sounds like Transformers.
3, 2, 1. All right. Let's see if we've got anybody in the chat that has an idea.
So we do have one person, Robert, that selected high static. And again, if you remember earlier, I said, in a constant torque motor, when static pressure goes up, it is going to increase its current consumption. And anytime we increase current, we increase heat. Anytime we put more heat in an electrical product, we are going to decrease its life, but it's a very small amount of increase of current related to the changes in static. So
Okay.
the number one failure mode that we have found, and this is just from getting motors back and identifying, why did it die, is water damage. And so if you've ever talked to me on tech support, and if you have, I hope it was a good experience. The first question you're going to hear me ask is, especially if somebody says, well, why did it fail? First question I'm going to ask is there any rust on the shaft? And the reason I'm going to ask about rust on the shaft is the shell is painted, the end shields are aluminum. The only part of this motor that's really exposed that's steel is the shaft and the through bolts. So if you see a motor coming out and you have a lot of rust on the shaft or a lot of rust on the through bolts, and we call those through bolts because they go through the shell, they hold it together. That's an indication that the motor has been attacked by water. Either it's been had water thrown at it, or it's had water condensing on it. And in the constant torque motors, that's what we find is the largest cause of motor failure. Now, you had one apart earlier, and I've got one somewhat apart here. You can see that on our constant torque motors, we do have this
a good one.
The potting compound in here. And that potting compound covers the electrical components. And so that is going to protect them from getting wet, right?
To an extent, yes.
That's a great answer. So is that potting compound making it waterproof or water resistant?
Just resistant. And it's really only to your contact points of your electrical components and your wires.
Right. So there's a circuit board underneath all that black goo. And, I don't know if everyone else is, here in Wisconsin, the state fair is a big deal, go see the cows and buy your corn and all that kind of stuff. And there's always that one guy selling that waterproofing stuff for your basement, and he's got the one brick that's treated and the one brick that's not. And he's showing how a brick is porous, at a microscopic level, and water will get through it if it's not treated. And, so I use that kind of ha-ha analogy for the potting compound in that motor. That potting compound at a microscopic level is porous. And if you get it wet enough, long enough,
it's going to absorb the water.
You can absorb water and you can fail that electronic control. So, my gauge for that, again, going back to, I'm talking to someone on the phone, my gauge is, do you have rust on your shaft? And not to draw this out into a long discussion, but it's funny when a technician will say, well, it's in an air conditioner, of course it's going to have rust on it, there's water in there, and the irony of that statement is that many motors are downstream from the coil, and they're actually in a very dry environment, right? They're in the most dry air that there is in the house, because the coil is obviously removing moisture from the air. So why is there water on the motor? And in many cases, it's because it's condensing, not necessarily because we're throwing water at it, but because we've got a cold metal surface. And of course, if the metal surface is below the dew point of the air around it, we're going to condense water on it. And that warmer, humid air that's above the dew point is probably not coming from the coil. It's probably, being infiltrated into the cabinet through loose doors or other things. So that's the number one reason that we found, and that's a little bit of background on, looking, what can help you look for failures. The other question I get the person mentioned the static pressure. We kind of debunked that a little bit. The other question I get is, well, what about voltage spikes? So the constant torque motors have 4,000 volts of surge protection built into the motor. So, and you can show your picture of your control, and somebody will always ask me, like, oh, is it that little round disc? Is that the surge protector? And that's not really the surge protector. If anyone remembers from the last show, that's actually an inrush thermistor. But intrinsically in the design of the control, it can handle 4,000 volts of surge without failing the components. So anything less than 4,000 volts of spike should not fail that control. And I like to beat that one up a little bit because technicians like to say, well, there was just a thunderstorm recently and that control failed, so must have been the thunderstorm. And it could have been, but if it was a voltage spike high enough to hurt the motor,
should have had some other parts.
Probably should have been other parts in the home. Yeah. And the last thing I'll say on that point, not to belabor it, is, we may not have had a voltage spike in the home that was high enough to increase the line voltage value high enough to fail the control. But keep in mind, the low voltage inputs to this motor have thresholds as well.
Yeah, that's true.
And what I hear, because I haven't been in the field for a little while, what I hear is that many transformers are now commonly operating daily at 27 or 28 volts. They're nowhere near the 24 volt threshold. I just
had a 29 volt here at my own house. I was actually doing some work here in the garage, and I heard a slight hum, and I thought, I know that familiar hum. Went outside and I could hear it coming through, and I got the meter out, and I had 29 volts coming through.
Well, of course, and you know why they hum, right?
Mm-hmm.
They don't know the words. I thought you.
Boy, there's a dad joke that's got to get written down. Oh my gosh, I love that one.
That'll be on. It's really bad. I shouldn't have said that out loud.
No, yes, you should.
Or while we're being recorded. So. So back to the spike. So it may not have been a voltage spike that was large enough to damage other components in the home, or even high enough to damage the line voltage side of the control. But if I go above around 30 to 32 volts AC on those low voltage inputs, I may have failed the input that turns on the motor. And so what I do ask technicians sometimes is try a different tap.
Yeah.
If the motor's not working on that tap, try a different tap. And some technicians will find that another tap will work. Now, it's quite often that other tap only works for a little while, and then
it might be enough to get it up and running while you're getting the replacement ordered.
Right. But that can be an indication that maybe that tap, was failed by a line voltage surge that wasn't large enough to cause any other line voltage damage in the home, but was enough to cause that transformer, which I'm sure and you could teach better than I could. It's a gear, right? So whatever comes in goes up. Whatever comes out is going to go up as well, to a point.
Yeah.
So, all right, I beat that one up enough, and I don't see any other questions on that one. So we'll talk about replacement, and this comes back to the control question and I think the programming question. So try and make sure to answer all those. So if you're going to replace it with an OEM motor, you need to go back to the OEM of the appliance. And that sounds like I just accidentally said something stupid, but I actually did mean exactly what I said. I get asked quite often, well, can a carrier motor work in a train? Can a Lennox work in a ream? And the answer is, I don't know.
Right.
If they both had 24 volt speed taps, then yes, it's going to quote unquote work. I don't even know why I do that. That is so 80s as well. But it will, I don't know what tap is going to give you the right airflow. And as you've learned today, if one motor is PWM and the other one is 24 volt taps, or one is 9-speed and one, so there's quite a few variations today. If you're going to go with the OEM motor, just go back to the OEM, skip eBay or Amazon or wherever else you're buying it, and just go to the OEM if that's what you want to do to get the correct motor. One question I didn't answer in the last show, and I will cover it now. So on our motors, there's usually a model number, and I don't know if you can see that. I'll hopefully took the glare off. There's a model number, and it usually there's a gap in the model number, and there's some larger numbers at the end of the model number. And quite often I'll get a phone call where somebody says, well, the first 7 digits all match, but those last 4 digits don't match. And usually that's when I say, let me guess, you ordered it off of eBay, and they ordered one that looks very similar to what they needed.
It's a half horse. It should work.
It's a half horse 230. It's good to go. So those last digits usually denote who we sold the motor to.
Oh, okay.
It could have denoted one OEM or another. It could have denoted a motor that we just made in bulk, and any OEM bought that one because they didn't need something special about it. but also then keep in mind that not only could those 4 digits mean we sold it to a different OEM, it most likely means it's got a different program in it.
Could it be
right?
unprogrammed?
It could absolutely be. Man, you're awesome. You're a great host. You do your homework.
I'll
So
try.
I do occasionally get calls where a technician will say, I bought a replacement motor from the OEM. The OEM's name will be left out to protect the innocent here.
Yep.
And it doesn't run at all. And they want to know, is it a DOA motor? And I say, well, depending on where that motor came from, if the distributor programmed the motor, which some do,
Yeah.
the OEM sends them unprogrammed motors and the distributor programs it. If the distributor didn't program it correctly, it could be DOA or it could just be not programmed, right? Which to the technician is, well, who cares? To me, it doesn't work.
Right.
I still got to take it back. But I have actually encountered technicians that have gone back once or twice and keep coming back with motors that don't
Same
work.
non-programmed batch of motors. Sure.
So in that particular circumstance, I usually will say, I'm not saying that we can't make a motor. I'm not saying that every motor that we make is perfect. I'd like to say we do, but I'm a realist, right?
Right.
There's a chance one could not get made perfectly, but 3 in a
Chance
row,
of the batch.
very, very unlikely. You're probably running into a programming issue, and you should go back to the distributor or the OEM and talk about programming.
Or get you a good gen tech and just set it up properly.
There you go. Or get yourself a universal motor, which we're going to talk about next. So
there you go.
We make a universal motor. I think I mentioned it earlier. It's called the Evergreen EM. The Evergreen EM has the standard 9-terminal plug. It'll replace all of these, our motors and competitors' motors with the standard 9-terminal plug.
Right.
And it will replace them in both 24-volt and PWM mode. So it'll also replace the N-site and the motor that has the leads out.
Wow.
On those 2 motors, we include, I thought I had it with me. I don't, I'm sorry. We include a parts bag with some terminals in it. Because if you didn't look real close at this plug here, the LGN terminals are actually 3/16, and the C1 through 5 are actually 1/4 inch.
Sure.
So we provide all those terminals. You'll be able to cut this harness off. We'll tell you how to put the right terminals on and then plug them in the motor, and you're all done.
Man, there you go.
Same thing with N-site. You can cut the plugs off the OEM harness, put the terminals on, and plug them in. And I know a lot of people like conversion harnesses, right? I just want to plug, be done. But the thing about using the OEM wires and repurposing the OEM wires is those wires then are still going to match the schematic.
Yeah, the color coding. Yeah, exactly.
So if you use a generic harness or use an adapter, you've now the next person that comes to work.
Yeah, I was gonna say it's really good for the next guy.
Yeah, they're gonna be scratching their heads. So just to recap, we can do all the 24-volt AC standard 9-terminal plugs, ours and our competitors. We can do the 2 variations, the leads out and the N-site, and we can also do PWM. Somebody asked this earlier. Do I got to program the Evergreen to do PWM?
Right.
You don't have to. So pin 1 on this motor. These are smart motors. This is going to blow some minds, and other people are going to be like, "Meh, I should have figured that." Pin 1 will automatically recognize either 24-volt
either AC or DC
or PWM, and it'll automatically take off and do. So if you give it 24 volts AC, it's going to be tap 1, which is low speed. If you give it PWM, it's going to operate at whatever that PWM value is based on the min max, and the min max in the Evergreen is the full range of the motor.
And why hasn't every manufacturer picked up this motor for a single stock motor?
Many have. Many distributors are moving to stocking this motor because even the distributors that have their own OEM have picked up this motor because
I like it.
You can't always have all of the OEM programmed motors in stock, and this motor you can have in stock. And to that end, we just we just recently launched the dual voltage version. I went a little Sean Connery on you there. God rest his soul. So we now have a dual voltage Evergreen EM. It used to be 8 motors.
Yeah.
4 115, 4 230.
Yeah, absolutely.
And we did that early on simply because the majority of the industry wanted 230 volt. We built it in 115 for the small market that it was. But up until 2019, almost all constant torque motors were in the 230 volt air handlers and package systems,
Yeah.
you know, going all the way back to the 2013,
Yeah, beneficial
2006, 13
Yep.
SEER regulation.
Mhm.
But now that, you know, FER is 4 years in
Mhm.
our past, now we need a dual voltage motor. So you look at this chart, you got 4 motors, but really the majority of the motors that we build for our customers are in the half to 3/4.
Mhm.
So if a contractor did put a half or a 3/4 dual voltage motor on their truck, they're probably going to have the motor on their truck to solve all of these needs.
Yeah. That's an
Um,
ultimate truck stock right there.
it is an ultimate.
I'm
Well,
all about truck stock.
yeah, that's what we are
Mhm.
all about, truck stock as well. So
Mhm.
that was the big value for getting this motor to dual voltage.
Man.
You can see the picture there. I can kind of hold it up for you.
Yeah.
This is what the plugs look like. They're not that big. You just take it out of the box. You plug it into the motor. The white one is you can see it on the screen better than my hands, but the white one's the 115. The orange or yellowish one is the 230 volt. Simply put the plug in the motor and you got a dual voltage motor.
Okay. I am digging that.
Yes, sir. So any questions on the motors before we wrap it up?
Yeah,
Did we get
chats,
them all?
I'd say so. A little bit about the rocking.
Oh, I like that one. Yeah, Ray. Great question, Ray. So our Evergreen motors, they and I didn't even mention this. Thank you for bringing up a value point I didn't bring up. The Evergreen motors are also dual rotation motors, but they do it automatically. When you first install it in the HVAC system, it will run both directions very, very slow, noticeably slow. And
Mhm.
what it's doing is it's measuring the current draw while running the
Absolutely.
motor
Yeah.
at the same RPM in both directions. The
Huh.
correct direction of a forward curve fan blade uses significantly more energy than the
Mhm.
incorrect direction,
Mhm.
and it will automatically pick rotation. So
Well, how about that?
one comment to make about that, and there's usually a sticker on here. There's the sticker, and what that sticker says is, "Do not run me on a bench," because if you take
No
it out of the
load.
box and
Right.
run it right here, it's going to run back and forth and back
And
and
it's not
forth,
gonna
and
know.
well, you know, and I go back to what was that skit with Johnny Carson where he put the thing on his head and, you know, tried to get Karnak, right? The Karnak. The motor doesn't know what direction the wheel needs to go when the wheel's not touching the motor.
That's
So
great.
there's got to be at least one person out there that remembers that. Everybody else is going, "This
Yeah.
guy's old." Uh,
Yeah.
so yeah, first time you operate the motor, it needs to be in the HVAC system so that it can pick the correct direction. If it doesn't, we do have a process. It's in the manual where you put voltage to a couple of terminals for a
Mhm.
minute. And you take that voltage away, it'll automatically change direction. We also sell, and if I was still in the field and this was my truck stock motor, I'd have one of these. We sell a reversing plug. It actually goes inside the motor. You had mentioned it earlier, I think. You know, if I was going to use this as a warranty replacement motor, right? I go to a customer's house, they got a motor in warranty, but the OEM motor's not available, and I want to get them running, right? It's middle of winter or it's, you know, summer in Dallas. Got to get them running. I can put this motor in, wait till the warranty motor shows up, take this out. This becomes my emergency motor, right?
Absolutely.
I go to the next house and they need the opposite rotation. All I have to
But
do
it's
is
been programmed.
whip out my voltage plug, throw it
Yep.
inside, takes 1 minute to install it. Motor changes direction, and I can just keep changing direction by putting that plug in and out of the motor. And
Winter's
it go,
coming. Everybody hear that? You need to
yep,
have one on the van.
there you go.
And a plug.
There you go. I see it. So that answers
Yeah.
the starting question. I see, is there a 460 volt version? There is. So the 460 volt version is called Evergreen CM. So the Evergreen EM, as you can see on the screen, is now dual voltage, 115, 230. We make an Evergreen CM that's available in 277. It's actually 208, 230, 277. And we have another version that is in 460 volts. I see a question about contacting me. We'll cover that all the way at the end.
Sure,
And
absolutely. And more resources if people are looking for, all the varieties of motors. You can start with the dealer toolbox that will get you onto the website, and then you can backtrack into the actual product page.
yes, sir. Do you think we got all the questions? Can I wrap it up for you?
I think so.
Okay.
Yeah, we're doing good here. We got people still hanging on, so they're obviously still interested.
All right. So I'll wrap it up. We have an app. Everybody has an app. Our app, in my opinion, as a former technician, is something you can actually use on the job site. You want to cross-reference our motors. If you've got a Gentech or a formerly branded GE motor
Mhm.
in your hand, you can click on the Resource Center, go to ECM cross-reference, enter the model number, and it will tell you exactly which evergreen you need.
Wow, that's fast.
No charts, no, I think it looks like this, and I think if it's a GE or Gentech motor, we can cross you directly to it
Man.
in the app. That Resource Center has quite a bit of other information, a lot of the diagnostics we talked about, videos and PDFs, distributor locator should you need it, and even an induction motor locator. So if you have a PSC motor and you want a replacement for that, by the way, we do make evergreens that replace PSC motors. But if you want a PSC replacement for your PSC motor, God forbid, you can go to this part of the app and you will enter in, like you've probably seen other search engines, you'll enter your horsepower, your voltage, your RPM, rotation, all that, and it will tell you exactly what motors you can use, and that'll cover Century, Fasco, and Gentech. It'll cover all those brands. Our Motor Mastery University that you mentioned earlier, you got the QR code there. That is, if you have our app, you have it right in the palm of your hand. These webcasts and your podcasts will be in our Motor Mastery in the podcast tab. We've got Tech Tips, Motor Minute. They're videos. They're a couple minutes long. All of our manuals, all of our video, all of our training. Fasco Facts, right? Anybody that knows anything about motors learned it from Fasco Facts.
Absolutely.
That little pamphlet. I should probably have it here, but I don't. It's a PDF. It's in there. It's free. So a lot of not just Gentech, Fasco, Century information, but a lot of general motor knowledge in there, all at your fingertips and all free. Talked about the optimizer in the last one, so I won't talk about it here. That's for replacing variable speed motors. Yep. And then the tech support tab, I'm really proud of that. We built that tab just for techs. You're on the job. You don't want to wade through my website and marketing material and everything to get what you need. You need the manual. You need the video, how to install it. You click on tech support. There's going to be one more click, whether it's the EM, the VS, the IM, one of 4 motors. If it's the EM you're working on, you click on that, and you now have the manual in your phone and a video on how to install it. So it's on-the-job tech support. In the manual, there is a phone number to call me if you need me, but we make it as easy as possible for you to get the information you need there. Anyone that's watching is a distributor, or you like to learn from home, the same information is at dealertoolbox.com. So the app is the Dealer Tool Belt. Pretty slick marketing here, huh? The website is the Dealer Tool Box. All the same information I just went to in the same place. One last shameless plug. I think you're gonna put it up on the screen anyway. Regal MMU. That is our training site. We've spent a lot of time, because we have multiple brands, Century, Gentech, and Fasco, a lot of tribal knowledge over the years of induction and ECM motors. It's all in one place for you. Like I said, video, podcasts, tech tips. You can sign up for the tech tips. We'll send you one every month when I do it. Really, I think, really great general motor knowledge that you can learn while you're on lunch break or in between jobs, not when you're driving, please. And then one last shameless plug for a book that I wrote. If you really want to be an ECM motorhead, I did write a book, Everything You Would Need to Know. A lot of, there's chapters of stuff that you don't need to know on the job, the theory information, but I wrote this book. It's not, and I'm not picking on engineers. This book was written from this standpoint of a technician. So it's written in a way that we can understand things, but it goes into, you got the motor already pulled in half there. It goes into, what do those capacitors do? What all those components do? Why does the motor ohm out like a 3-phase motor? Because it is. Goes through all the theory of the motor, but then the last 3 chapters are basically following what we're teaching here. How does a constant torque motor work? How do I diagnose it? How does its airflow work, and so on and so forth. So that's my last shameless plug.
Love it.
I'm a Star Wars geek, so I'm going to make sure that I answer all the questions with my little stormtrooper there.
And you're going to be at the National HVACR Education Conference this year. Is that correct?
I will. I'll be teaching a class, and I will have a booth there to answer any questions you have.
And bring your books with you if you want to get the book signed by the author. I would love that. If you bring a book with you, we'll make sure that we have a book signing of authors while we're there.
There you go.
So hopefully see you all at the National HVACR Education Conference. Thank you, Jose. It is just a great training. And we hope that you all come back next week and hang out with us. And next month, we're going to be back again with Chris. We're going to be talking about ECM condenser fan motors.
Yes, sir.
And the following month, we're going to actually dive into some more characteristics of ECMs with airflow, and maybe we'll tear some motors apart and dive a little deeper. So if you have some ECM questions, get them prepared. And Chris, thank you so much for hanging out with us once again. I enjoy diving into ECM motors and getting a better understanding of these newer technologies.
It's probably more fun than it should be.
Hey, I love it when I get the calls. I had so much fun on your show. And
Exactly.
You had fun talking about motors. Do you
I look forward to these shows.
I do too. All right. Well, I think we're going to call it a wrap. We really appreciate everyone hanging in as long as you have. I know it's a lot of information, and we really enjoy hanging out with you and being a part of this HVACR and building science community. And Chris Mohalley, we will see you in a few weeks.
Sounds good. I know it dates the show, but happy holidays to you and your families, everyone.
Absolutely, everyone. Thank you so much. We'll see you later.
Bye.